Section 5.1, Properties of a Parallelogram, Day 2. Same objective as before, we're going to apply the definition of a parallelogram and the theorems about properties of a parallelogram. Our class opener for today, write down as many properties about parallelograms as you can. First sample problem. Quadrilateral GRAM is a parallelogram. Why is angle G supplementary to angle M? Well, if you look at angle G and angle M, they happen to be same side interior angles for two parallel lines. And we know that same side interior angles are supplementary. Part B, why is angle M supplementary to angle A? Well, angle M and angle A are also same side interior angles for parallel lines, so they're going to be supplementary as well. Part C, consecutive angles of a parallelogram are, and we just went through that they're going to be supplementary, while opposite angles are. And if you look at opposite angles, they're not supplementary, but they happen to be congruent to one another. Let's look at problem 3. In quadrilateral ABCD happens to be a parallelogram. Find the values of x, y, and z. So if I start to look at x and want to know what's its value, if I look over at angle A being 65, I notice those two angles are corresponding angles, and in the past we've stated that corresponding angles are congruent, so I know the value of x happens to be 65. Trying to find the value of y, I can look at the angle A and angle C, and I know they're opposite angles in a parallelogram, so they also have to be congruent, so y is going to be 65. Or you might have noticed that the y and x are alternate interior angles, and they would be congruent for that reason. Okay. Trying to find out the value of z. Well, I know that same side interior angles happen to be supplementary, so if I want to find the value of z, just take 180 minus 65, and you get 115. Let's skip over and look at number 5. Trying to find the value of x. Well, I notice x and 110 are vertical angles, and we know vertical angles are congruent, so x is going to equal 110. Trying to see what the value of y is. Well, y is going to have to do what? Well, I know that it would be alternate interior to that one, but that doesn't help me out. Okay. So what else might you notice? Well, it's in a parallelogram, but I can also look and see that it's inside of this triangle. And I know that these three angles have to add up to 180. I don't know what the angle is in the center unless I look at the 110. I know 110 and the angle right next to it form a straight angle, and a straight angle has to be 180 degrees. So the angle next to the 110 is going to have to be a 70-degree angle. Now I can look inside the triangle and see 70 degrees, I'm up to 140. So y has to continue that all the way up to 180, so y is going to be 40. Let's find the value of z. Here's z. Well, this one works nicely because alternate interior to that is 70, so I can get that z is 70. Let's look at another one. Must quadrilateral EFGH be a parallelogram? Can it be a parallelogram? Explain. So let's look at number 6. Okay. Well, number 6, I have corresponding angles being congruent. So I know that HG and EF are parallel. I have these two angles being congruent, and they're also corresponding angles. So that gives me HE and GF being parallel. So both opposite sides are parallel. It must be a parallelogram. Let's look at number 7. Number 7, the first thing I notice is opposite angles are not congruent. Well, we know in a parallelogram opposite angles are congruent, so this one is not a parallelogram. Number 8, looking at the two angles. Well, they do add up to 180 degrees, which would give me same side interior angles adding up to 180 degrees. Means the top is parallel to the bottom, but I don't know if HE is parallel to GF. So this one can be, but it doesn't necessarily have to be. Quadrilateral ABCD is a parallelogram. Name the principal theorem or definition that justifies the statement. Let's look at problem 9. Segment AD is parallel to segment BC. Why would you know that? Well, we know opposite sides of a parallelogram are parallel based on the definition of parallelogram. Let's look at number 11. Number 11 states that the measure of angle ABC, just sort of in the bottom right-hand corner, equals the measure of angle CDA, which is the upper left corner. And why would those two angles be congruent? Well, one of the theorems tells us that opposite angles inside of a parallelogram are congruent. Let's look at 13. 13 tells us that AX, so the distance from A to X, is half the distance from A to C. Well, if I look at A to C, why would you know that AX is half of AC? Well, one of the theorems tells us that the diagonals bisect each other. So if the diagonals get bisected, they get cut in half. So segment AX should be half the length of segment AC. The coordinates of three vertices of parallelogram ABCD are given. Plot the points and find the coordinates of the fourth vertex. So let's start by just plotting the points. A is located at 3, 2, so we're going to go right 3 and up 2. B is located at 8, 2, so 8 to the right, up 2. C we don't know. D is at 0, 5, so just going up 5. Now, try to locate the other portion of our parallelogram. Well, if I look at from point A to D, to get from A to D, I could go up 3, left 3. So from B to C, I'm just going to go up 3, left 3, which should be here. Then if I connect the sides together, I should be ending up with a parallelogram. And I just need to note that the values for C would have been the ordered pair 5 for the X value and also 5 for the Y value. Each figure in exercise 19 through 24 is a parallelogram with its diagonals drawn. Find the values of X and Y. Right. I know for this one that if I look at a parallelogram, I know that opposite sides have to be congruent, but each of the opposite sides has two variables. So let me write down what we at least have so far. I know if the top is congruent to the bottom, that I have 2x plus y equal to 36. Since the left is congruent to the right, I have 4x minus y equals 24. And now we have two equations with two variables, and how do we solve that? Well, one way we have to solve systems of equations is by trying to add the equations together and see if something would get eliminated. And I noticed that if I look at these two, if I currently add them together, the y values will cancel each other out. So let's go ahead and add. So 2x plus 4x gives me 6x. The y's cancel. 36 plus 24 is 60. Divide each side by 6, and x equals 10. Well, now I need to figure out what the y value is. So I'm going to go back to one of the original equations, and it doesn't matter which one, I'll just pick the top equation, and I'm going to substitute the x value of 10. So if I substitute in the x value of 10, I would get 2 times the x value of 10, which is 20, plus my y value equals 36. Subtract 20 from each side, and you get that y equals 16. So you now have x is 10, y is 16. Quadrilateral DECK is a parallelogram complete. So let's fill all this information in as we read through it. So measure of angle 1 is 42, so I'm going to fill that in right away. The measure of angle 2 is an x squared. All right. The measure of angle CED is 13x. So this entire large angle down in the right corner is 13x. And we're supposed to find the measure of angle 2. All right. So let's see. I know that opposite angles in a parallelogram are congruent. So I know if I add the two angles together in the upper left, it should equal the angle down here in the lower right. So let's see what that looks like as an equation. So the x squared plus 42 should equal 13x. Well, to solve one of the equations with an x squared, let's get everything on the same side and factor it. So subtract 13x on each side, and you get x squared minus 13x plus 42 equals 0. All right, now it's time to factor. So I checked, there aren't any common factors, so I'm going to try to split it into two parenthesis groups. I know that x squared is x times x, but now how do I do the second part? Well, I need to try to come up with two numbers that will multiply to 42, but add up to negative 13. So I'm thinking, what are the numbers that can multiply to a positive 42, but add up to a negative 13? Well, I could start going through the whole list, or I could start to figure them out in my head. I know that if numbers are multiplying to 42, they have to either be both positive or both negative. And if they're going to add up to negative 13, that's only going to happen for two negative numbers. So can you think of two negative numbers that when you multiply them, you get 42, but when you add them, you get negative 13? And hopefully you're thinking that it's negative 6 and negative 7, which would add up to give you negative 13. So back over here, we get minus 6 and x minus 7. Well, how do you solve this? Well, if two quantities are multiplied and the answer is 0, it must mean that either the x minus 6 was 0 or the x minus 7 was 0. Solve each of these equations. If I add 6 to each side, I get x equals 6. If I add 7 to each side, I get that x equals 7. So if I look back at our original problem, it says, then the measure of angle 2 is how much? Or the measure of angle 2 equals how much. So it gives us that there are going to be two answers. Well, if I look back at angle 2, I notice that angle 2 is x squared. So I really need to figure out angle 2 is x squared, which if x is 6, x squared is going to be 36. And if x is 7, then x squared is going to be 49. So my two answers are 36 or 49. Your closure for today then is explain how you solve an equation with two variables. You can do a sample problem if you want, or just write down in a couple of sentences how you would solve an equation with two variables.